Alright, so I'm gonna be riding my bike while I do this recording. Doing some other things, maybe grocery shopping. If I can get leftover candy. I'm looking for leftover candy. It's on sale. I don't have a lot of money. Like, I haven't gotten my food stamps back yet. Two is a reason that I didn't really hit. Well, I've got my food stamps renewed, I just don't have. They haven't come in yet. Yeah, kidding. It's like, alright, so parallel twin cylinder, 2-cylinder, diesel. It's the kind of same concept as single stroke air injectors. Instead, I'm going to be using diesel fuel as the injected fuel because it's kind of easier by far to do that when I don't have like a ginormous amount of money. Because my thought process went like this: there are certain standard size diameters of steel tubes, and it's like, well, I can probably find an old abandoned truck or something. And then I was like, well, back in the day, anyways, point is, I came up with the idea and concept of like, well, so I came into what is the equivalent to about 42 inches roughly of steel, chromoly steel, half-inch thick, inner diameter 5-inch chromoly steel tube, right? And I was like, well, I can do this. It's not gonna be impossible, especially when I can get some basic mild steel plate. It's not that insanely impossible to just grind it down in certain areas and then, heat it up and press it into place with, a little heating and, like, what is it, induction heating along with electrically resistive heating put together in a nice little sandblasting chamber, a little tiny one, as long as it's in a vacuum and has some silicone caulking. I get to actually getting it to weld off of that with a little hydraulic fluid press. Just inside that little tiny one, get out the hammer, bang, bang, bang. The hydraulic fluid press, junk, 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 and it's like, well, it's welded. I know people would think it wouldn't be, but it's like in a vacuum, it gets heated up. It means, yeah, basically it welds. It's a vacuum weld. I don't need nearly as much effort to forge weld because, like, I'm not trying to forge it. But it'll weld. It's a vacuum weld. So it's like, well, I've got the tubes, and I'll just try and grind out some little channels, and then I'll turn it into those with some thermal epoxy, little channels into some aluminum sheet, some holes every so often in them. And he's like, well, there's going to be some liquid there. I still have to bolt them together at the top and bottom. The tubes. I still have to then do everything necessary to make all that work. Like not too bad. It's just like some drilling, some welding. It's like chromoly is a little bit more in terms of like its outright strength and hardness, annoying as fuck. But it's like, for what it's worth, it exists on a lot of old vehicles, and people don't maybe know that. That's where the whole point of it was. It's an old 70s. I was like, an old 70s personal semi truck or driver that wanted to ultimately run their own rig, but it made sense to do something like that. So that's basically where I got it. It's like I found like a fucking chunk of damn chromoly steel, and I was like, you know what, this will work. This is absolutely something that can work. work with, and a little quarter-inch, steel plate that has some half-inch areas I found also off of another vehicle. Apparently, there's something to do with drag racing, or I don't know, just protection area, I guess. So it's like, well, it's already pretty much able to be bent. It's only about this size. I mean, this is a 20, let's see, I calculated it was 21 something inches, and it's 5-inch side diameter. It's a 1 liter, but it's like, because I'm going to be using the type of technology I want to use, which means I have air injectors with my supercharger, which, it's not like fall off something. It's gotta go to the junkyard and go find an old diesel that was only about 1 liter big. I made a bunch of aluminum tubes, different sizing, but then some aluminum sheet, which was hard to find, but eventually was able to. And they make thinner aluminum sheet that's not like aluminum foil than your standard aluminum sheet, right? But then it's like, yeah, except I don't really want to do that. It's expensive. It's really expensive. Both shipping and the thing, so I was like, what's over there? You got some aluminum? It's already aluminum sheet. Like, I can just squish it if I heat it up, and turns out it's pretty difficult to squish aluminum. Like, not really realistically, but I have to get an actual like roller press to make that work. Yeah, and so I just didn't want to. But I really just found old aluminum sheet from some broken up radiators. I was able to repurpose some braze welding. Everything's braze weld. So it's like start off at a smaller tube, then to a medium-sized tube, then to a larger tube, which is a Jules Thompson, with some fins in between, which with the right Z depth, totally possible. So then it's from there going to be able to go back to a smaller version and repeat the cycle. And you have to have a little bleed rail to the other side of the reservoir because it'll have condensed. So, which means like now I've got a cooler. Didn't need it. It never got fucking hot enough. I have a ginormously long stroke. I have a hugely, ridiculously long stroke comparative to my bore. It's like over 20 inches of stroke for a 5-inch bore. Like really getting it honed down, like make sure it's all really slick, smooth on the inside surface was the better part. Like, I had to go to machine shop for that one. I had to get certain drills and taps at the top and bottom, to chromoly, so that way I could drill and tap and then make both the tubes and the engine block part of each other by bolting them together with some flush bolts. And it's just running a pump around the cylinders. Well, there's liquid there. Turns out is more than good enough at being able to apparently transfer enough heat and never really need for me to worry about turning the pump on because the thermocouple still worked. I tested that one. Nice boiling, water and so on. But then it's like, okay, so I did all of that and you work. Why not this? Turns out it just never gets hot enough. But the reason why I did it was because it was like, well, this is a diesel concept that uses. Okay, so the Diesel goes in, it vaporizes off, has a low flash point, but there's no air in there. Alright, so as a result of there being no air, it vaporizes, but then it's going to go back to being compressed. It's going to go back up to its top dead center. I still have to get heads, but heads weren't that hard to find. Out. Because that's plates. It's a couple of plates of steel. And it's like, if you don't know, like, just bolting them and putting some braze weld and all that, it works out. Yeah. Just heat them up really hot in a vacuum. And then they melt together. Just grind them down to the right size and shape. Mill them out. Then it's get out the old drill and get out all the rest of it that I need. So that way I have one exhaust. That's right, an angled exhaust with valve covers that I can put on this fucker. It's literally what I did for each one of them, right? But they're off to the side with a center and intake. The supercharger is genuinely just for my small ass little turbo. Yeah. There's this like, well, here's a bunch of gearing from the crankshaft. So like the crankshaft is actually, technically speaking, for its given stroke, it goes to a bunch of gears along the one of the sides at the bottom of the parallel twin here. So it's mostly because it's never going to go above 50 RPM. Never goes above 50 RPM. As the way I burn diesel is I'll start injecting air towards top dead center, immediately get to a high enough compression range, but mostly enough heat as it'll be pretty lean, and then I blow more air in. To be able to make that work. Which just means the air injectors are just pushing air, regular old air, but I have a supercharger and a nice little rail, and then a couple of one-way valves, and I throw away the water cooler, the liquid cooler, the engine cooler. Well, I didn't throw it away, just put it somewhere else. I was like, well, maybe I can use that for that. It's like, it's not really necessary for freaking diesel, especially on that side. I was like, 50 RPM, right? I was like, yeah, no, big old stroke length. And then it's like, it's a bunch of gears that effectively mean I have an overdrive from the given stroke length to the point where it's at my transmission. So it runs along what are the sides, the flat sides, so it's like you have the two parallel tubes, and then one side is the exhaust area, which is up at the top, and at the bottom would be where the gearing and crankshaft would be.
But I made it. You made it. You did good.
Excuse me. How's this? Alrighty. I did not like any candy. Let's get that.
Bye, Ashley. Bye. Be safe.
Yeah. Alright. Oh, okay. Alright, so the basic premise from the bike kind of engine here is the fact that it's like, well, the cadence of a given engine is what makes it sound. So it's boom, 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 boom. for like a person bike pedaling. Boom, 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 boom. And not really meant for going above about 50 RPM, maybe 100 RPM at most. And then I have insane levels of torque because gearing is this one stroke actually equals about 5 to 10 strokes for the crankshaft, depending on how I set it up. Which means more torque for gearing. But it's like, yeah, you'd think that, except for the fact that diesel also happens to be able to burn fairly decently at high enough temperatures that you'd be surprised how well, reasonably speaking, you'd be able to actually achieve a really, really high amount of brake manufactured pressure. As you burn diesel, as you place in the air, it's like, since you wanted to ask, turns into, oh, what do you know? Yeah, basically, it's more like an actual engine with the way it's set up. Now, blowing in air is all about knowing about the pressure inside the cylinder and the nozzle that outputs the pressure at a given pressure for its received air gaseous fuel. Although in this instance it's air, so as long as the pressure remains at the right amount, then that's all that's necessary. And it'll push it in at the right amount, the PSI, through the nozzle, and still burn. Just have to pulse it right. That's kind of the whole premise of like, well, a diesel injector is like 50,000 PSI. And I'm like, yeah, okay, what if we do? But like, it doesn't come in that way. There's a nozzle there. That's why that's a certain reservoir, a given size of work energy within inside of that, which is the diesel injector shaft, the camshaft-like device. And so as a result of pumping in, let's say it was 90 PSI, because it happened to then shrink the given size of volume inside of the injector, and then it's forced through nozzles at around that 50,000 PSI. That's how injectors work, right? So it's like, well, a few air injectors will work just fine if you do it right. Literally, no issues there. Now, other people don't usually know that, which is why I look at them funny when they say it can't work. So they're usually not very bright to me, because I'm like, you're running an engine, you make all these power and whatnot, but then you don't actually know how your engine works or the physics that are involved. Which then turns into like, yeah, well, it just goes burr well. You wouldn't believe me. And then it's like, hey, let's just talk about this. Force equals mass times acceleration squared. Since the piston head is accelerating for a longer given duration at this stroke, because I'm continuously burning the fuel that's in it, that means it happens to gain more force, because the lever is an extended given amount of lever force to a greater amount of rotation. That means I also gained more torque, because it acts like I have an even longer lever, where the work energy took itself over a longer distance of time to do. Except now it's like, yeah, but you thought, bitch. Here's a lot more pressure in your cylinder. And that's why it goes boom, 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 boom. And it's like, no, it won't work, it won't work. Meanwhile, here's something I like talking about. Here's a top dead center cylinder pressure. right where the head is, head pressures, right? Well, this accelerates it as an initial bump. Think about a graph right in front of your mind. You know what I mean? You can imagine it right there in your mind. You don't have imagination? Then just make a graph. But it's like, as from zero, it'll go way up to its actual current speed. And that acceleration is its given force. Now, the pressure that's there then does work energy as it expands, right? But that given initial acceleration and then the expansion of that pressure drops. So you'll look at this pressure and it drops down over time, acceleration, initial acceleration, but then speed goes up. But it actually goes up a lot slower over its given distance of time down to its bottom dead center and has to slow down at middle dead center. All right, that's how you calculate for pressures to torque. Not just levers, not just links, and not just gearing. Now, if you happen to not have an insanely high head pressure, what you can do is continuously accelerate it as it's traveling during its stroke. As long as it doesn't break the head pressure and gasket pressure that can be sustained, then it will work just fine. You just have to make sure the piston speed slows down in time and it doesn't exceed the material strength of the given crankshaft and gears. Which is why it's like, actually, you're stupid and I'm smart, and so actually, really realistically, you should have shut up a while back about it not working. I continued to accelerate the piston past top dead center by maintaining higher pressures. Instead of increasing pressures in a given cylinder volume, I maintained top dead center head gasket pressure. Which means when I do that, that actually increases its duration of delta time acceleration. Now, you can increase cylinder pressures. Cylinder can handle it because there's a larger amount of surface area, but your head gasket can't. Your head can't. So it's like, this is your max. You can't go above it. And for what it's worth, you can't go past between middle dead center and bottom dead center of acceleration. Or attempting to keep acceleration, which acts like an increased mass by reducing its degree of resistance to deceleration. But that's why you get thrown rods when you do that. So it's a very delicate dance you have to play there if you want to. As all of it is a given mass that's accelerated over a given amount of time at a given RPM for a given amount of pressured force inside of the cylinder. Which is why it actually works out to having such high torque, and why the stroke length matters so much, and why the way I'm running a diesel makes no sense to most people except for me. It's like, oh yeah, no, I can absolutely get compression ignition. That's fine. Burn! Continue the burn! Continue the burn! Do more burning! Yeah, okay, stop. Which is effectively the equivalent of, this is our delta V, and this is our impulse in rocket mathematic physics. And so our delta V is the given gas that we have in there. This is the amount of gas we can put in to increase the impulse of our delta V inside of a captured cylinder. So, long story short of it was, well, it's really just a mimic like the cadence of a bike. It had 100 foot-pounds of torque. It would only go up to 50 RPM, which meant I had to get a transmission that's a bunch of overdrive gears with a crankshaft that's effectively an overdrive gear too. So it's like, no, boom, 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 boom. Man, you must really want to be getting going somewhere, right? You know, it's like what that feels like. But it's not really what that is. It's like, no, I just don't feel like switching gears right now. I mean, yeah, boom, boom, boom. Like, do, I was just doing that. You know, it's like an engine thing. And I was having fun with it. And then it turned into like, well, what would be required to make a bicycle level cadence work as an actual motorcycle? It is 1 liters. Humongous shark length to bore. It's never going to go above 50 to 100 RPM, and I don't need it to because fuck that. Have you ever tried pedaling at 100 RPM? It's not easy. 50? Oh, super not also easy in any way. Also not easy. So, I was like, you know, this is easy enough to figure out. And then I can make it such that the stroke to the crank with the gearing there is a lot easier to make a lot better outright types of duration of its power stroke. So duration turns into, basically a little bit past middle dead, between middle dead and bottom dead, I'm still able to get a power stroke. Which is like just a nice little J hook effectively. I'll suddenly zoom down and then rapidly accelerate back up at the top. Which is why it's like, that's actually where my new middle dead is. I mean, my bottom dead. Because that's where my exhaust starts, considering it's about to rapidly expand and then collapse again. Which could be dangerous if I don't time it right. So it's like, yeah, that's where my exhaust starts opening. Boom! Big old booming over there, but then I have gearing for the supercharger. So that way it maintains a consistent RPM throughout the very little RPM I have to give people. Now it's a 1 liter and it's a 100 foot-pounds torque, but then it's like, instead of having the engine be the RPM, it's like it's all gears. So I have more than enough torque, more than enough, literally more than enough torque. It's really about gearing. Overdrive gears to overdrive gears to overdrive gears. Yeah, and normally you wouldn't do that because you don't have enough torque. You just go really fast. And this is just a different way to do it. So if you don't know, it's like, well, the reason why it works the way it does is because you didn't know that the way we ultimately get our given torque value is fundamentally able to be changed. Like continuing to burn past a top dead center from an initial combustion to be able to maintain cylinder pressures, which is fine, is totally doable. It just means I'm going to burn for a little longer, which is fine. I mean, I was going to push that kind of fuel anyways to get those numbers. Which now, because I can burn it more cleanly, more thoroughly, I can actually run with less fuel, but also still manage to get less heat. It's only slightly hotter than it would have been if I had tried to do all of it at once. Or, well, with my initial, so it's like, it'd be hotter if I did all of it at once for that amount of air and fuel, but if I were to run it as for normal without that, then it's only slightly harder, which is good, because that means it's efficient use of the given heat energy, exothermic, kinetic, to transfer of work energy for its pressures. Come on, Kaiser, come on, get in there. Nope, nope, nope. Come on, I got you. Jeez. Phaser, really? Come on. Come on, Phaser. Come on. Come on inside. Come here. Good boy. Good boy. Jeez. He freaked. Trying to run from the bike. It's okay, Phaser. I'm sorry about that. Yeah. Anyways, that's like the whole premise of how I managed to get more, like I have a much larger amount of air and fuel to give someone, but I don't. I just make it accelerate past top dead center as best I can. That's really all it is. Like, that's the math behind the physics of most of internal combustion engines. Like, an electric motor gets away with having multiple points of acceleration, and it's given 360 degrees of rotation, right? Which effectively for it looks like I constantly accelerated from its 12 all the way back to 12. Except there's resistance, there's slip, and there's, a given amount of energy that's wasted in that duration. Now, it's more efficient than an internal combustion engine, don't get me wrong, by far for transferring its energy, but it's not a full 360 degrees that it actually manages. There are little moments where it doesn't. And it's where it goes repulse to attract to repulse to attract to repulse to attract. And like in that moment of trying to attract, the only actually technically is like a flywheel, or the magnets act like a flywheel as they'll attract. As the repulse can be much higher than the given attract from a given magnet. Which is like the whole reason why I have a bunch of weird repulse engines that are able to dynamically change repulse strength and attractive strength. Z current pinch would be fine if I could get current levels at that level, but it's like, nah, I'm not gonna do that. I know they're like, no, do more Z pinch. I'm like, good. That's a brush motor that'll melt if I fuck that up. Like, it can melt anything with very little voltage. So I turned into the guy that goes, let's listen to reason. This guy that goes like, so there's a given amount of gas, I just need to force more air into the cylinder. That's literally it. It's like, as long as I get the right compression at the very top, that's compression ignition. And as long as I continue feeding it air, that's continued burn, which means continued force increase for the given acceleration that's going on. For the mass remaining pretty consistent for the lifetime of the engine. Like, it'll wear out a little, piston heads can wear out a little. So, like, that's kind of what that turns into for me, especially when most engines will never go, like, for instance, like a semi-truck engine will never like do more than like 55 consistently, right? And it still wears out after like a couple 100,000 miles. So you have to basically repair and replace things pretty often. And it's like, well, here's a bike cadence. Boom, 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 boom. Just big, long strokes. To give her the beans. Yeah. And so that's what it turned into, because that was easy. Once you start an initial acceleration, to continue accelerating is much easier. Standard Newtonian law stuff. In motion stays in motion more easily, especially as you can continue increasing acceleration by maintaining a given amount of pressure to force what it is look like to it a continual top dead center push as it goes down. So that's fine. If you want to increase, you have a exponential problem. It can start instead of linear, exponentially increasing, which is very, very dangerous. which you don't need to do. So I was like, here's how to bring diesels back, boys. It'll burn more cleanly as there's more than enough air to burn all of it. There's no fucking way you're not burning all of it because of the amount of heat it's going to go through, breaking down basically all of the soot and more as it continues to get hot enough from where the air is being injected to then forcefully create these oscillating waves as you have to inject, not just constantly. You think it's a thrusting type of injection. You can't do that. They're just regular injectors. So like you can get up to 3, 4, maybe at most, and you can rotate the injection to help it to basically achieve a greater efficiency and a better burn for the given amount of time you really have. Which is why for some of my other designs, they're just ginormous diesel injectors that are solenoid activated that have a lot of pressure pushed to them, but also they're a totally different nozzle. Like I basically drilled out the nozzle so I have more volume every time. These are little methane injectors that I found, which can push air just fine. Like methane is a gas, air is a gas. It can push air, so like there's nothing wrong with that. Yeah, it's never gonna get hot enough because they're recessed into the plate, which was 2 plates. So I got mild steel and a mild steel. Basically grind and bolt and try and get them to weld a little bit. But it's like, this is why it's only ever got the one valve. This is the valve. Here's a gear reduction and all that to make sure it all matches with the actual stroke. Right, which is really more like this part of the crankshaft, which huge long stroke length, you know what I mean? So it's like over 20 inches, which is what it would have to be. Okay, so it's like very close to a full 1 liter. Like I filled it up on a little, in my head, a little mat, rubber mat, after I built the engine block around the 2 tubes, and was able to get a full liter inside of both of them, total for both of them. But like that was slightly under with the little surface tension water thing going up to the very top. And then I still have heads. So the piston heads is like, well, 5 inches isn't impossible to find as piston heads. What you got over there, junkyard? 20 inches? Are you kidding me? Yeah, like literally there's a lot of that because it's like, oh yeah, boom, boom, just constantly. But it's like, I got 100 foot-pounds of torque to give you. I don't have RPM, but I have a lot of torque, right? Which is all gearing and stuff. That's one of the reasons why it was like, I don't know if you know this, but like, I can definitely do things people think they wouldn't have to worry about. You know what I mean? Like, no, it's a diesel on a friggin' motorcycle frame. What's the big deal? It's only like it's a diesel. They make no power. Zing! What are you doing? Boom, boom, boom. You know what I mean? Like crazy levels of stuff, right? And yet you'd want it. You do. Like at 20 inches, like you can horizontally get that done. That's what it is for an engine block for an inline 4. You know what I mean? That's totally doable. So when I thought about it, I was like, well, I can absolutely put this on a motorcycle. And then, yeah, sure, it's diesel, but like, not your kind of diesel. No offense to people with diesels out there, but it's like I wanted to burn all of the soot. You know what I mean? Like have no particulate matter left. Which is why like I first bought my own diesel, sure, but it was like, I'm gonna make my own diesel. Which turns out not that impossible if you know how to do some solar and hydropyrolysis with a little bit of oil involved. You get diesels that you can filter with a centripetal and centrifugal style, and then it was like this is a circular style as it presses in, filter. So instead of like being like a cloth or something, it has to have multiple layers. So it starts off small, gets medium, gets larger as I get more and more pressure to be able to go finer and finer micron to as fine as a micron as I can really get. So that one turned into, I was like, well, carbon, activated charcoal is not stupendously the best. I was thinking about old used ones. I was thinking about like cloth, like canvas to cotton to other things like that. I ended up settling on like a really small type of ceramic sieve that the coffee people use for pour overs. It's a pour over filter, ceramic. But it was like, yeah, that would totally actually work. Like, so long as I could get it pushed through a proper, kind of like espresso filter now. After that, because like espresso, they do have these little puck filters that survive. And so it's like, well, I'll go through the pour over, and then the espresso is like really small little micron. And then it's like, look at my diesel. It's diesel. Definitely diesel. Like, no matter what, I made that diesel. I used sun and wind captured and made my diesel. Because 36 bottles for hydrogen is intense, and I can't store it easily. It's not immediately a liquid. It takes a lot to compress it, condense it. So, diesel. Got old trash bags or stuff I could find for plastics and whatnot. They worked out with some organic. So, but for what it's worth, like it runs off of any fuels. Like I just started with diesel. It can run off of ethanol, propane, natural gas, butane. I've got any methanol, any regular gasoline, any liquid and air fuel will run off of. I have to switch the injector a little bit, for the air, like the gaseous fuels. But like liquid fuels, it's just like whatever the hell you want to put in me, I'll work, I guess. Turns out certain lower heat value fuels are better than higher heat value fuels. Not because I can burn more, but because I can get more work energy out of them in a given period of time. It's not about the heat, it's about the amount of density. Okay, so like a good way to phrase it is density, the amount of gas for this given heat value has to be very managed. So it's like if I have a higher heat, I have to basically square heat to get a certain amount of actual increased pressure because it lowered its density. But if I increase that density, but I kept the same heat value, I actually increase pressures faster than if I were to try and just make it hotter. Basic, physics, thermodynamic physics. So that's what that turned into for me. I just wanted to make a bicycle cadence, like diesel, that would show people up for like boom, boom. Like I'm going up to my 50. Boom, 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 boom. I'm not gonna fucking lose. The fuck? Where'd he go? And I win on the quarter-mile drag strip again. Look at him. He's got himself like a nice souped-up little engine, He's like, 12K, oh yeah. Meanwhile, me, boom, boom, boom. I'm gonna roast this motherfucker at the end. He's still trying to get down the track. That's what I did it for. It was literally just to be like, you don't even know physics. Look how cool I am. I know physics and engineering and stuff. Fun stuff. Anyways, just wanted to record that. All right. Bye.